In this video, I'm going to go over determining whether a function is even or odd and learn to tell the difference. First of all, we're going to start with just looking at the graphs, because you can tell just by looking at a graph whether a function is even, odd, or neither. Well, when we say that a function is even, that means that, at least in terms of the graph, when you reflect the graph along the y-axis, that'll be the vertical axis here, negative y, this is positive y. If you reflect it, flip it across that, like you're folding a paper, you would get the same graph that you started with. Okay? It has to be the exact same. It can't be off even a little. And then that would mean that it's even. Okay? The mathematical way of saying that is, let's say that this green graph here is f of x. If f of x is equal to f of negative x, then it is even. It means all the outputs, or the inputs, actually, misspoke there. All the inputs, all the opposite, then you would end up with the same graph. In this case, it is, right? We input negative 1, we get out positive 2. We input 0, we get 1. Input positive 1, we get 2, right? Positive 1 and negative 1 have the exact same output, 2. So, therefore, this one is even. And if you flip it across that y-axis, you will end up with the same exact parabola, right? All right, look at this one. Same thing. Flip it across the y-axis, you end up with the same thing. Same exact graph. See how easy this is? Well, maybe not easy for me to write. All right, now let's look at this one. This one's a little off, right? It's not symmetrical across the y-axis. So when you flip it over, reflect it across the y-axis, you end up with something like this. It's way off, right? That is not the same graph you started with, okay? Well, so we know it's not even, but is it odd? Now, I haven't gone over what odd means yet. With even, you're only reflecting it across the y-axis. With odd, you're reflecting it across the y-axis and the x-axis. So it's not even, because this dotted line, let's just put even question mark and circle with a line through it, okay? Now, if you then reflect that across the x-axis, now you're checking to see if it's odd. And is that the same as this green graph over here? No. It's not the same there either. So this is neither for that particular example. All right. Now, what about this one? You've reflected across the y-axis, you end up with this, right? That's not the same. So it's not even. But what if we reflect that across the x-axis now? What do we end up with? The exact same lines, or line. So this one is odd. Make sense? Same with this one. This is a x cubed kind of graph. See, it's going up one direction and down the other direction. kind of a good rule. That means it's odd, usually. But it needs to be symmetrical. Now, my drawing is crude, but just take my word for it. It's symmetrical across the origin. Now, what do I mean, the origin? Well, with even, it was just symmetrical across the y-axis. But with odd, it's symmetrical across the y-axis and then the x-axis. So it's not really symmetrical across either axis. It's symmetrical across the origin. That's what we call it. It's being reflected across the origin. Kind of like it's being reflected across this diagonal line. You know what I'm saying? Or maybe this line. No, it's more like this line. If you picture that, that's what happened when we reflected this twice. We reflected it across this imaginary, y equals negative x line. Okay. Now, if you do that here, let's check to see if it's even first. You end up with that. That's not right. But if you reflect it again across the x-axis, realize this arrow would now be pointing down. And this one is now pointing up. And you're right back where you started, which means that this one is odd. And our last example, it's not symmetrical. You can tell right away. When you flip this over the y-axis, reflect it across the y-axis, you're way off. Then you reflect it again across the x-axis. You're left with something like this. I'll just ignore that. Still not the same graph that you started with, so this is another neither. Neither even or odd. Now, there is one function, one line, that is both even and odd. You know what it is? It is the x-axis itself. How does that work? Well, flip it across the y-axis. It's the same, right? It's even. All right, now flip it across itself, the x-axis. It doesn't go anywhere. So the x-axis is both even and odd. All right, in part 2, I'm going to go over how to determine if it's even or odd without the graph. All right, let's stop looking at all those terrible graphs that I'm drawing and let's actually do the math version of determining whether a function is even, odd, or neither. Okay? Now, when we're reflecting something across an axis, the y-axis, to determine if it's even, right? We substitute the inputs for negative inputs, okay? Just put those parentheses and you put a negative x in for that x, all right? So what happens when we take negative x cubed? We have negative x times negative x times negative x, right? Well, 2 of those negatives are going to cancel, but 1 is going to be left, so we're still going to have negative x cubed, okay? Negative x times 2, negative 2x. Is f of negative x equal to the original equation? No, it is not. So it is not even. That's all we know so far. Now, to determine if it's odd, we got to take this now and reflect it across the y-axis. We're reflecting it across both, right? So we need negative of the function and the negative inputs. Negative output, negative input. To see if it's symmetrical across the origin. Okay, so and then by doing that, all we do is multiply what we just did, because we already did f of negative x, by a negative. Multiply it by a negative, right? Because whatever that is, it ends up being is going to be our whole output. So we multiply it by a negative and we get negative f of negative x, right? So you distribute that negative 1, right? There's an understood 1 there. And it changes the signs. So negative f of negative x equals x cubed plus 2x. Now, is that the same as our original equation or function? Yes, it is. So what does that mean? It means it is odd. All right, that's the math version of how to determine if a function is even or odd. Basically, we start with this. If it's even, then great. And we don't have to do the odd part. If it's not, then we do the odd part. And if it's neither, then we say neither is our answer. Could be neither. All right, let's do h of x. It's h of negative x. Well, it'll be negative x to the 4th, right? Plus 3 times negative x squared plus 7. Negative x multiplied by itself 4 times. There'll be 4 negatives. They'll all cancel each other out. So we're left with x to the 4th, right? Plus negative x times negative x, positive x squared. Okay. Plus 7. Is that the original function? Yes. So it is, in fact, even. What about this one? Last one, I swear. G of negative x. It's positive. It's a positive. It's even, right? So when we put a negative x in there, it's going to come out positive. This is an odd exponent, right? Which means it's going to come out negative. Is that the same? No. That middle sign changed. Okay, so let's do negative g of negative x. What happens? All the signs change. And it's still very different from our original equation. And not just because of this, because, I mean, we could always move this over and change all the signs again, but, I mean, that would just mean that this becomes negative again, and we're going to end up with that, so it is neither. Thank you for watching.